Unit 2, Lesson 3, or Unit 3, Lesson 2, excuse me. Unit 3, Lesson 2, quadratic function. So a quadratic function is in the form of ax squared plus bx plus c, okay, where a, b, and c are real numbers, and we call that general form, okay. We'll get to that in a little bit. But essentially what you're looking for is an x squared. If you have an x squared as your leading degree, that's going to be a quadratic. It's going to be a parabola because that's what's growing the fastest. Okay. Okay, it can be written in the form like when we're solving for a quadratic equation, then it's equal to 0. That helps find the x-intercepts, the roots, and the zeros, as we know. Okay, so we've already done that. So that's nothing new than what we've done. So here's the two forms that we're going to talk about that you need. We're going to be able to go between these. This is essentially the whole unit. Okay, moving from general to standard or standard to general. Okay, those are the two forms for parabolas. Standard form is nice. If you want to make a note, standard form here is easier for graphing. Okay, standard form is easier for graphing. So this one's kind of the graphing aid. Okay, because it shows you the stretch and it shows you the vertex. Gives you a lot of the placements of the parabola itself. Okay, and so we're going to hit the standard form today. That's our first thing we're going to analyze for quadratic functions. All right, so analyzing the graph of function of y equals x squared. So we're going to look at just regular y equals x squared. Okay, we know that y equals x squared is a standard parabola. If you plug 0 in, 0 squared 0. 149, 149 the other way, just showing that symmetry, okay, because they grow the same rate on both sides. So one thing I do want to point out that I just did, and I think sometimes it's an oversight, is that I actually didn't go over one, up one. I went, okay, over one, up on this side, and then I said, okay, if I'm one away from the middle here, I'm one away from the middle here. Because these are symmetric, right? They're both 1, they're both 2, they're both 3. So you could do that. Once you kind of have one side of your parabola, you can be like, okay, here's the center. If I'm 3 this way, I got to be 3 on the other side. You don't have to keep going over 3 up 9, over 1 up 1, over 2 up 4, okay, for the symmetry. Just pointing out the symmetry. The reason I'm pointing out symmetry is because the axis of symmetry is the mirror line which splits the parabola in half. That always, okay, listen, that always goes to the vertex. Your axis of symmetry always goes to the vertex. And that makes sense, right? Because the vertex is your lowest or highest point. That's when it changes direction. So your axis of symmetry is this guy right here, right? It just goes right through the middle. Okay, AOS, axis of symmetry. I'll put AOS. I won't always write that out. So if you see AOS, that means axis of symmetry. The vertex of the parabola is where the axis of symmetry intersects the parabola. The vertex can represent a minimum or a maximum. So for example, this guy right here is a minimum. It's a valley. Okay, your other option is if you have a parabola doing this. That's a maximum. It's a hill. Okay, so if you're maximum or minimum. Okay. Label the vertex V. Vertex is a coordinate. For example, this one's vertex is simply 0, 0. Okay. Max or min value of a quadratic function occurs the vertex as represented by the y-coordinate of the vertex. So complete the following. So what that's saying is that when you have a vertex, the y value represents your min or max value. Okay, so this one's, I know it's 0, so 0 is my minimum value. That parabola is never lower than 0, which makes sense. There's nothing below the x-axis. Okay, so what this says is the blank value of the function with the equation y equals x squared is, so it's going to be, I think they're talking about, sorry, let's go see what they're saying here. The minimum value. The min value of a function with the equation x squared is 0 for this one. Oh yeah, the one that we just had, I just said that. So okay, then we're just going to state the domain and range. Okay, and we're going to start looking at how this moves or what standard form does for us, okay? Any questions so far? So remember, we're talking about standard form primarily. Okay, standard form of the parabola. All right, so real quick, domain for parabolas is XER. Okay, it's always going to be all reals. Okay, because parabolas grow forever left and right. The range for the x squared, though, is 0 is the minimum, so that means it has to be greater than or equal to 0, because 0 and higher. All right, now we're going to start analyzing the movements of the parabola through a couple investigations, and then we got a couple examples. All right, so let's look at how is standard form built. What does standard form do for us? So the next three investigations help us explore some general transformations. So these are going to be transformations of the parabola. What's really cool is if you get really good at these, your Unit 2 in Math 30 will be a cakewalk, because they have a test on transformations tomorrow. Okay, so x squared relationship has a standard a, x minus p squared plus q, where a is 1. The transformations operation moves or maps a figure from an original position to a new position. So I'm just going to highlight this here. P and Q are your vertex. We'll talk about that in a second. But they are your left, right movement and up, down movements. So P is your left and right. Q is your up, down. We're going to get to that in a little bit. A is your vertical stretch. Okay, so we'll get to all this stuff. I'm just kind of giving you all the information first, and then we're going to go through it and kind of confirm it. So we're going to look at the graph of x squared plus q. So we're going to figure out what does q do to the parabola. Okay, so that's what we're doing here. What does q do to the parabola? All right, so f of x plus 3. Write an equation that represents each of the following. So f of x is x squared. So we're simply just going to write y equals x squared plus 3. This one is y equals x squared minus 3. Because f of x is x squared, they tell us. So use a graphic calculator to sketch it. I'm not going to do that right now. I'm just going to go ahead and sketch it. So what happens is, for example, if I put a 0 in, what's 0 squared? 0, but then I have plus 3. Right, so it's going to be 3. So if we do this one in yellow, that means it's going to be there. Let's put a 1 in. 1 squared is 1 plus 3, 4. So instead of being at 1, 1, we're at 1, 4. Yeah, you meant 4, but that's fine. Okay? And then 2 squared is 4 plus 3 is 7. Okay, and so you kind of see this is how it's growing. Okay. Okay, so it definitely moved up 3. Plus 3 moved up 3. Simple. Now the minus 3, you would go ahead and assume it's going to move it down 3, which you're right. If I put a 0 in, I get negative 3. If I put 1 in, I get negative 2. If I put 2 in, I get 1. And so here is the minus 3. And so it's clearly the q there moves it up or down based on what the number is. Okay. So let's just look at these, and then we'll do a general. This is like the q just means in general, what does that mean? So if f of x plus 3, the representing function is x squared plus 3. What's the new vertex? 3. Yeah, 0, 3. Moves it up 3, right? It's still a minimum because it's still a valley. The min is now, instead of 0, it's 3. Axisymmetry is the same. Okay, translation. So vertical translation, 3 units up. Okay, and I'll just continue filling this out for the other ones. Minus 3, so 0, negative 3, min, negative 3, x equals 0. Vertical, just put vertical t, down 3. Then f of x plus q, x squared plus q. Vertex would be 0q. That's a q there. Try to make it so it's a little bit easier to see. Okay, min at q. Still x equals 0. vertical translation Q units. Okay, I know it's getting hard to read down there. This pen's been really getting a little bit sketchy on me. So x squared plus q, 0, q is the vertex, minute q, x equals 0, still your axis symmetry, vertical translation q units. You can put q units up since it's a plus, but if you put q units, and that kind of talks about if it was a minus q. Okay, so that works as well. Okay, so finishing this off, any questions on vertical? I think vertical is pretty straightforward. You're fine? Okay. All right, so we got, what is the effect of the parameter q on the graph y equals x squared plus q? It's a vertical translation. Okay, compare to the graph of y equals x squared. The graph of y equals x squared results in a vertical translation. If q is bigger than 0, the parabola moves up. Q is less than 0, it moves down. Okay, we'll stop there for a second before we move on to the next piece. So vertical straightforward, it's what you see. We're going to adjust investigation 2 just a little bit, and you'll see why in a second. All right, same type of thing. We're going to look at 2 graphs, going to see what they're doing. Okay, let's go ahead and give a little bit of, do this one red. So f of x plus 3. So what happens is that means x plus 3, what's that? Close? So y equals x plus 3 squared is how you rewrite it, because x plus 3 goes in for x. So if we try some points here, what happens is if I put a 0 in, let's start with 0. Where am I at now? Right, 0, I'm at plus 9. So that's like off my page. Okay, so what about negative 1? Negative 1 plus 3 is 2. 2 squared is 4. Yeah, so negative 1, I'm at 4. Okay. Negative 2. Negative 2 plus 3 is 1. 1 squared is 1. 3, negative 3, that's your 0. Now you kind of see what's happening there. It's on the left. It moved left. Let's do negative 4. Negative 4 plus 3 is a negative 1. Negative 1 squared is back to 1. And so now you see the symmetry taking place. So that's 2 away. So there's what happens. So which way did the graph move? Moved left 3. But you saw plus 3. So what would you expect from a plus 3, though? You'd expect right. So this is the thinking you have to do. It's opposite for horizontal movements. The reason is because it's actually, and this is what you guys should understand from your last unit, it's what makes the inside 0. What makes the inside 0 is a negative 3. Negative 3 plus 3, right? So if that makes 0 inside, if I'm doing a negative 3, then that means left 3. Okay, so by putting a negative 3 in here, that makes this 0. That moves that left. Okay, so then conversely, you can see the x minus 3. Okay. Right, so if I put 0, I get 9 again. If I put 1, I get 4. Put 2, I get 1. It's there, it's there, it's there. And so you see this one moves right. Okay. Okay, so we didn't have to use the graph calculator sketch. We already did that. I'm going to fill this table out with you. So we already have this stuff. So this is y equals x plus 3 squared, y equals x minus 3 squared, y equals x minus p squared. So the vertex, the y doesn't change, okay, but the x does. Okay, so it's going to be negative 3, 0, because it moved left, right? Yep, negative 3, because it's left. This one's 3, 0. This is what I like you to put. Put negative p, 0, and I just do that because it's opposite of what you see. Okay, that's more of a thing. Technically, it's a p, because they have a minus there, which is telling you opposite, but for whatever reason, students tend to forget to flip. So just always think opposite of what you see for p. Okay, so our min value doesn't change though, right? Because we're moving left and right. So we didn't move up or down, so our y doesn't change for our min. So this one's always, this is 0 for all these. So we didn't move up or down. But since we moved left and right, our axis symmetry changed. That thing cutting it in half did change. So it's going to be x equals -3, x equals 3, x equals -p. I really want you to focus on this, please, because this one's always forgotten. This axis symmetry always matches this number. 3, 3, -p, -p. It always matches the x value of your vertex. It's supposed to. That's how it goes through the vertex. Okay. So this one I'll just put HZ for horizontal. So horizontal translation, 3 units left. This one was H horizontal translation, 3 units right. And this one's horizontal, yeah, P units. And then you can maybe put opposite here if you want, like opposite of what you see for P. Okay. All right. Now we're just going to do a little bit of a combination, a couple examples, and call it good. Okay, so we're going to do a combination of a left and up and down. Okay. All right, so we just got to finish the bottom here first. What's the effect of the parameter? So you just say it's a horizontal translation. I know this is redundant. I get it. Okay. Compared to the graph of y equals x squared, the graph of y equals x minus p squared results in a horizontal translation shift of p units. And then I remember opposite. If p is greater than 0, the parabola, so if you see, this is what I'm saying, if you see a +3, you move left. Okay? I want it to be what you see. They do a switch on you, and I'm trying to take that out for you. If you see, if p is less than 0, so if you see a negative, you move right. Okay? All right, now let's put them together. Last page here. So we have a combinations. We have an x plus 2 and a minus 4. Okay, so that means it's going to look like this. F of x plus 2 would be x plus 2 squared minus 4. So let's just all together here. What would those two movements be? Left 2, down 4. Left 2, down 4. Why left 2? Because a -2 is what makes that 0. We want the opposite. We keep this one normal, down 4. Okay? So predict, so we just said, we know it's left 2, down 4. Okay? So if we do this, it'd be x plus 2. So the vertex is now what? From 0, 0, it went left, so -2. -4. Went down 4, right? Left 2, down 4. Minimum's down -4. Good. Axis symmetry is -2. Yep. And description, left 2, down 4. Okay. And then let's do the generalities here. Minute Q, sorry. Minute Q, axis symmetry, -p. Okay. P, left, right. It's a left there. It's awful left, but Q, up and down. Okay, so the thing you gotta know, the thing I could keep putting on there on purpose, and your notes, my notes have it opposite. They keep saying P. But remember, your x value for your vertex is the opposite of what you see with P. Yeah, min's Q. Min is your Q. X is negative P, the opposite of what you see with P. That says P's left and right, Q's up and down. Yeah, sorry, pins needs to be adjusted. Yeah, maybe that's why I got to take the thickness off maybe. Okay. I'm going to try that, see if that helps. Okay, so let's do some examples and we're done here. We've got this set of examples. We'll call it good. Okay, so describe the two graphs of following functions relate to graph y equals x squared. So let's just pop around. Miller, what is the first one doing? Yep, left 10, that's it. Thank you. Left 10, that's all. Okay, Emily, what do you think the B is doing? Couldn't tell me. Up 4. It's outside the x squared, guys. Outside the x squared is up and down. Okay. Abby, how about C? Okay, good. Right 5's correct. Tricky here because we need this over here. How would you move the 8? Minus it, so it's down 8. Yeah, it's all right. That's how you learn. Again, I appreciate wrong answers. That's how we learn. The following transformations are applied to the graph y equals x squared. Write the equation that would be. Okay, so Gavin, what would the equation be if I said horizontal translation 5 units right? So what would you for your equation? Yep. Minus 5 because you want to go right 5. So opposite. Minus 5 because you want to go right 5. Okay. Kale, what do you think for B there? So we're going left. So right? Yep. Okay. 6 down, 6 down, 4 left, 4 left. Good. All right, now, last one. Write the corner of the image of the point 39 on the graph x squared when the translation happens of 2 units up, 7 units right applied. So what it's saying is that point of 39 is where after these translations. So basically it's just saying, well, if I tell you you're moving it 2 units up, which number does that affect, the 3 or the 9? The 9, right? Up is your y coordinate. So that means it's going to be 11 because 2 units up, right? And 7 units right affects the x. 3 plus 7 is 10. So that point would now be at 10, 11. Okay? All right. Let's go ahead and pause this.